Section 4-2 today is over the applications of vectors, and we actually already did this lesson in class, so the first part anyway. I'm going to try and get through this first part a little quicker, just to feel like everyone was fairly comfortable with the content. So let's get started. And what we talked about was the general formula for finding magnitude, which is just how long is the vector in its hypotenuse. We decided that this equation for x2 minus x1 squared plus y2 y1 squared, this is the distance formula. And then we talked about how what we're doing with x2 minus x1 and the y2 y1, that's if you remember, that's how we got any vector in any position to get to the standard position where the start of the vector is 0, 0. So if you already have a vector in standard position as such, what this is saying is, well, you don't have to do x2 minus x1 because x1, y1 is 0, 0, or, well, I guess your second vector. So in essence, if you already have standard position, so if you have it in terms of like x comma y, that's when you can just square each term, add them, and square root them. Next, we're going to go to first example, find the magnitude of a vector. So here we are not in standard position because point A and point B are given, and they're not 0, 0. So the first thing we got to do is get it. So we're going to use that first equation. So let's see. We find the component form first, and then we do the whole square root equation. So component, whoops, I lost that. Component form is the 4 minus negative 2 10 minus negative 6. Which just equals 6. Sorry, there's no negative there. 6/16. So if we were to look at this resulting vector, we have like over 6 and up 16. So that's our vector. We want to know the magnitude. If we know that this side is 6 and that this side is 16, we want to know what the resulting magnitude A, B is. And that is just square root 6 squared plus 16 squared. Which is 17.09. We don't have units, it just gives us coordinates on the XY plane. So that would be our final answer then for that one. Now we're actually into a real world problem, an application problem. And what's happening here, we've got 2 kids pulling a wagon, and in class, you know, it's a classic problem. I'm sure you've been in this situation. You and your siblings are fighting over some toy or whatever, or maybe you used to, probably not anymore. But the third kid wants to stop the first 2 kids from pulling this wagon away from him, or him or her. So we need to figure out what is the magnitude of the resulting vector between kids A and B, or kids 1 and 2 pulling together, so that kid 3 can then apply a vector exactly opposite of that. In other words, what we're trying to do is find the magnitude of vector A plus B. Right? So if we find the magnitude of this resulting vector a and b, we just flip the sign for kid 3, and then we stop the wagon from moving. So vector a itself is, well, I'm going to draw the diagram here. So there is a hint in the problem. It says assume the wagon's at the origin, so the wagon starts here. And the one rope runs along the positive x. If you look at the diagram as a picture already, they're doing exactly that. So they're calling, so I'm just going to kind of darken that in a little bit. We're going to call the 30 vector, which we'll call vector A, the exactly on the x-axis. That then allows us to draw vector B at 28 degrees from the origin. See, if we don't put A on the origin, we just put it at some other angle, it complicates things. It adds way more work than necessary. But if we do this, we can see that vector A is 30 in the x positive, so that's 30 comma 0, because there's no y term. This vector does not go up or down. Equal sign. So B, though, I'm going to move that back. See, B does have an angle, and from section 1, where it says find the components of a vector at a given angle, we know that it's just, the x term is the magnitude times cosine of theta, and the y is magnitude times sine theta. So we just say B is 20 cosine of 28, comma 20 sine 28. And that just simplifies to 17.659 and 9.38. Now there are units on these. These are pounds, but just for the size of my screen and such. Oh, that's not good. Anyways, sorry, I don't know my computer if you guys saw that on your screen, but mine just popped up with several errors. Anyways, I was just saying units are applicable here, but with my screen and such, I'm leaving them off just so that I have room to write everything out. But these are 17 and 9 pounds respectively. And what we need to do, all we're trying to find at this point is just, A plus B. So A plus B. We just take our 30 and our 17, and we get a resulting x of 47. We have 0 plus 9, such, so 9. So we're halfway there, because now we have our resulting vector starting at 0, 0. It goes over 47 and up 9, which makes sense because our resulting vector should look something like that, because we do our head to tail method, however you want to do it. That's what it looks like. But that's not what the question asks. The question says, how much force must be exerted? So what we're really being asked to find is the absolute value of A plus B, which is what I mentioned up here. So that's just going to be square root of x squared plus y squared. Again, to save room on my screen, I'm shortening that to 0.6. Please go ahead in your calculators, use the whole 0.659 and the 3894. and so on. When you do this, you find that the absolute value of AB is, lost that again, it's 48.6 pounds. Of force. So go ahead and walk yourself through that again. If any of that didn't make sense, make sure to rewind, rewatch the video, but that's really all it is. If you're given multiple vectors, find the resultant. If you want to know, this does just say how much force. It does not ask what angle. If we wanted to, we could find that angle and so on, but for this problem, it does not ask. So we are done. I will do the next example here in the next video.